Hello everyone, this is Diego Saldivar and I am a Neurogames designer with an idea. And this idea has been informed this month thanks to a new tool that is being developed as we speak. Let me tell you a little bit more about it. I wanted to talk to you about Nathan Semerzidi's new PhD project in which he's creating a framework that allows designers and scientists to conceptualize brain-computer interfaces and interactions thanks to a new kind of vocabulary. Let me talk to you a little bit more about it. By the way, Nathan is the handsome guy right below. His PhD thesis is about creating a brain-computer integration framework wherein he uses two axes to classify the kinds of integration that we can expect from a given system. As you can see, the axes go from egocentric to allocentric and from semiotic to engrammic. We go from semiotic to engrammic, that is to say from abstract language into just flashes of information right into your brain. And from egocentric to allocentric, that is to say from just you yourself or you being the center of a network to you being part of a network. He classifies the quadrants that go from these two axes. In the superintelligence quadrant, you're supposed to be the center of the network where you are receiving all the information directly into your brain. Thus, your intelligence is added upon. Below the superintelligence quadrant, we can find the Psychonaut quadrant, wherein basically you're using a system to explore your own mind. Thus, Psychonaut, you're swimming around in your own psyche. The feedback is not as intuitive because it's more semiotic. That is to say, you're receiving abstracted messages. That can mean language, symbols, images, anything that is not immediately available directly into your brain. On the other side, we have the hive mind and the swarm. Basically similar concepts, but where brains are networking and where your brain is not the center of the network. In a hive mind, the whole affects the individual, and in a swarm, the individuals affect how the whole behaves. For more information, just go to Nathan's webpage and click on the links available to get a deeper understanding of what neural congruence is in general, what distribution of agency is. These are the two axes I talked about. And of course, if, for instance, you cannot quite understand what the distribution of agency has to do with the hive mind, you can click on these pictures and you will be sent to a deeper explanation. With these quadrants at my disposal, I participated in Nathan's workshop to test his framework, and this is what I came up with. So imagine, if you will, that you want to play a neurogame with this specific crown. The basic structure is your neurosity sends your brainwaves to neurosity notion, then they send back information into the computer to give you the focus on calm score, which then you can use in the game in order to give some feedback, such as, for instance, a sphere going up and down or fire burning, or in this case, to make magic attacks. More about that in a minute. And of course, you're using a controller to be able to trigger the attacks. Easy enough. In this first iteration, I concluded that I'm much more in the Psychonaut sphere because I am the center of the network. I'm alone on top of that, and I'm giving feedback in a much more semiotic way. That is to say, I use symbols to give information back to the player. That is the audiovisual feedback, such as fire, ice, maybe sound, maybe spoken words. Those things are being given back to the player as a form of feedback instead of giving information directly into the player's brain. How about I create an iteration where you get information back into the player's brain directly? That's where the second iteration comes to play. So how about we use transcranial magnetic stimulation to show a phosphene, that's to say a flash of light, whenever you get hit by magic. That would be a way of changing the integration of these brain-computer interfaces, so it becomes more engrammic. That's to say, you get more information directly into your brain in an intuitive manner. How about we extend the information that we're feeding into the game by using a neuromotor sensor into the hand in order to be able to make all kinds of signs and symbols with your hands to summon magic. So instead of pressing a button, you would be using a kind of magical hand gesture to summon magic. This would make the game a bit more semiotic because you're using symbols to be able to transmit information. Here you can see I'm using the Facebook kit, which is property of Facebook Reality Labs. I believe that the project is on hold for the time being, but if guys you're watching this, I am very interested in trying this out for my own designs. Wink. On the other side of the coin, let's say you want to be part of a network. In this case, I'm still not going into a neural network per se, but I'm adding another layer into the network. If you use the alter ego, which is an experiment by a student of the Massachusetts Institute of Technology, MIT, you see that they get also neuromotor information from the jaw, the face, in order to predict what you would be able to say if you were speaking, because this information is being sent to your muscles, even if they don't act on them. I'll give the neurology explanation for another day, but in this case, this information would be sent to another cloud for speech recognition, and then you can silently summon some spells without having to press a button for them, but you can still aim with your joystick, for instance, which is something that you would have done with your hands in the previous example. So that is fine and dandy, but how do I apply this to a neurogame? Well, as you can see, the first iteration was the basis of any neurogames that I would be making. So I actually already have a game pitch that I presented to the Sony Talent League. Hopefully they will accept it. Otherwise, well, I will just continue developing by myself anyway. So what I am presenting is Bakemono 5, and this is a bit of a pet project of mine where I have been iterating here and there, experimenting with different platforms. In this iteration, I would like to use Unreal Engine 5 and some assets I have already bought in order to be able to create a game where you use magic. In this game, you will be using different states of mind to summon different kinds of magic. Maybe ice requires you to be calm and concentrated. Maybe fire needs you to be not concentrated and not calm. We'll see what I can come up with. However, I want to make a change from the things I've been doing so far. So far, I've been using numbers, more than or less than, in order to see if the player is properly concentrated or not. But how about I start using vectors to see if concentration is going up or going down? Same for calmness, going up and going down. So if I use these vectors, I may be better able to use the player's mind dynamics instead of mind states in order to get information that will make the game easier and much more fun to play. So that's my plan for next year, because I will be taking a Christmas break. I hope that you have excellent winter holidays, and I will be seeing you around. Take care, and as always, send me a message if you found this interesting. Goodbye!